Write each rational number as decimal, tell wherever each decimal is terminating or repeating decimal. So first we have to change our rational numbers to decimals. How we do this? We will use long division. So in the first example we have to divide 24 by 99. Because 24 is less than 99, so we add 0 at the end, so decimal point, and few zeros. We can always do this because it doesn't change the value of our number. It still is 24, because zeros after decimal point is like nothing. So how many times you can put 99 to 24? 0. We take up decimal point. And now 0 times 99 is 0. Now we have to do subtraction. 24 minus 0 is 24. We take down 1 0. 240 divided by 99 is 2. 2 times 99 is 198. Now we have to do subtraction. 0 minus 8 we cannot do. We have to borrow 1 from 4, so here will be now 3, and we have at the end 10. 10 minus 8 is 2. 3 minus 9 we cannot do. We have to borrow 1 from 2, so it will be 1 here, and 13 minus 9 is 4. 1 minus 1 is 0, so we don't have to write. And next we have to take down next 0. We have 420 divided by 99. How many times we can put 99 to 420? 4, of course. So 4 times 99 is 396. Subtraction. So again, 0 minus 6 we cannot do. We have to borrow 1 from 2, so it will be now here 1. And at the end we have 10 minus 6 is 4. Have to borrow 1 from 4, so it will be here 3. And here we have now 11. 11 minus 9 is 2. 3 minus 3 is 0. We don't have to write. We take down next 0. So we have again 240. Divide by 99 is 2. 2 times 99 is 198. And again, subtraction. We have to borrow 1 from 4. So it will be 3. At the end 10. So we have 10 minus 8 is 2. We have to borrow 1 from 2. So it will be here now 1. And 13 minus 9 is 4. 1 minus 1 is 0. We don't have to write. So let's add 2 more zeros. We take down next 0. So we have again 240. Divide by 99. It's the same like here. So it will be 4. And again, 4 times 99 is 396. And so on. When we subtract, we will again get 24. We have to add another 0, and so on. We see that the number 24 repeats. So we can write that 24 over 99 as decimal, it will be 0.24, and because 24 repeats, we can add the bar on the top. It means that this number 24 repeats, 24, 24, and so on. When we cannot finish long division and the numbers or the number repeats, we say that this number is repeating decimal. Next example, we have 2 over 3. We will do long division to change this fraction to decimal. We divide 2 by 3. Because 3 is greater than 2, so we can add zeros at the end after decimal point because it doesn't change the value of our number. It's still 2 because zeros after decimal point is like nothing. So again, how many times you can put 3 to 2? 0. 0 times 3 is 0, subtraction. 2 minus 0 is 2. We take up a decimal point and take down 0. So we have 20 divided by 3 is 6. 6 times 3 is 18, subtraction. 20 minus 18 is 2. We take down next 0. Again, we have 20 divided by 3 is 6. 6 times 3 is 18. Subtraction, 20 minus 18 is 2. We take down next 0. So again, we have 20 and 20. It will repeat. So it means that we cannot finish our long division. Our number 2 over 3, we can rewrite that this is 0.6 with the bar above. It means that this 6 repeats. We cannot finish long division and 6 repeats. So we can write that our rational number is repeating decimal. This is my solution.